Yes, class. Good evening.
Good
Am I
evening.
audible? All right. So all are present. Abia, Madiha, Priyadarshini, Rifat, Sahal, Sami. So I have shared the scores that you have obtained from your tests that we had, the whole complete magnetics. So just see if you want to see your answer sheets. That also let me know. Madiha is there. No? Practice is required. See, derivations were missed. That's why maximum marks has been deducted. And very then slight calculations to extend to the power like this. Madhya Rifat has also given the test. Same thing, derivation for the axis. Samia is present. Samia hasn't joined. Samia. Fahad, Reem, Zaid, Wafia. Sahal is there, no? Sahal is there. So you all have not scored much in this lesson. I think one more test is required for magnetics. See, more or less, no, concept-wise, you people have done it correctly. Concept-wise, you have done it correctly. More practice is required because slight errors are there. Derivations people have not done. So practice it. By these scores, it won't work. Let me just see your scores. I'd send it on the WhatsApp. No, I hope you people have seen all your marks. Private servers, no? No, not magnetic events. So Rifat, Madiha, only Samia has done well in this batch, 22 and a half. Then Bafia, 17 and a half. Fahad, Sahal, Rifat and Madiha. See, out of 25, these scores are not good. At least above 21, you all should get at this stage. Please, class, prepare this lesson well. If you are having any doubts, what was the issue? You have not understood the lesson, or it was just lack of practice. Yes, Madhya? Madhya gets all the answers correctly in the class. What happened, Madhya? Lack of practice or what? Same with you, Sahal. You are also a very active child. Okay, Samia is there in the class. Samia has joined. Samia has done the paper well, I think. She's got, I didn't learn that, okay, derivations. Samia has joined. Samia has scored 22.5. And you also can do much better, Samia. You can get a complete full score in these kinds of tests. Even Sahal, you all have to improve, not only these two. Rifat, Fahad, all those who had appeared for the lesson. Abia, you didn't give the test.
No, ma'am, I did not.
Please appear for the test. See, though they have scored, many students have scored lesser score than usually they score, but see, now at least they are familiar with all those questions that we did. And ultimately, these questions benefit you at the end because you get practice. So, whenever it's possible, please do appear for these tests. And even if you score less marks, nobody is going to ask you how much you've scored in magnetic effects test in Learnivio. Ultimately, your board's marks will be calculated. And now we have all reached electromagnetic induction and the syllabus now will be moving faster. So please appear for the test. Give your test. Zaid has also, I think, not appeared for the test. Zaid, test nahi diya tha na? The test that had occurred, last test. Please appear for the test. 5 students only gave the test. Appear for the test wherever issues you are having. Get it clarified, because students who have given the test, now when I'll take the test again, they'll not be having issues. They have to revise this. And one more test of this lesson is required, class, because this will not go. These marks are not sufficient good marks for scoring well in your final exams. One more test I'll take. Same lesson, same thing, with different questions when you have it. 20th is Tuesday, no? 13th. Okay, then Tuesday. Next Tuesday, 1 week you have again. Weekend also you will get. Right now we will continue with EMI. So please, class, prepare more. Please revise it more and prepare it for the test. One more test I'll do. I hope you score good in that test. Magnetic flux we had started. Magnetic flux is basically number of magnetic field lines that is crossing area normal. Faraday's experiments are there. See, Faraday performed certain experiments. Few experiments using a coil and a bar magnet has been performed by Faraday. So it does not usually come to describe the various experiments that are performed by Faraday or Henry that ultimately led to the phenomena of EMI. These are for your knowledge. If just in case it comes, then you can mention. See, the first experiment says what? First experiment says a coil was there, circular coil was there that was connected to a complete circuit. Galvanometer was also there, and a bar magnet was there, north pole, south pole. As the bar magnet approached this coil with certain velocity, there was motion of current. Current moved in this, and that deflection was appeared. Why? Because of these magnetic field lines which are occurring. So because of presence of these magnetic field lines, there was deviation observed in the moving coil. Now, when the north pole was taken away in the same experiment only, when the north pole was taken away from it. So again, galvanometer showed the deflection, but in opposite direction. This way. Because the motion of the current got reversed. Why and how this we'll study in Lenz law. Lenz law, there you will study. But just remember this fact that what had happened, again because of presence of magnetic field lines, there was deflection on galvanometer. Deflection in galvanometer shows what? Deflection in galvanometer shows the fact that there's a motion in the current. Means current is there. Then again, a rough coil was looped back, galvanometer was there, bar magnet was there. Now in the third case, what had happened? Bar magnet wasn't moved at all. So V is equal to 0. Bar magnet will be having and exerting the magnetic field lines. There wasn't any deflection in the galvanometer. These points were observed. Fine. So when the north pole of a strong bar magnet is moved towards the coil, galvanometer shows a deflection in any direction. And when the north pole of the bar magnet was moved away from the coil, galvanometer showed the deflection in opposite direction. And when these same steps were repeated for a stationary bar magnet, direction of there wasn't any direction of current, and the galvanometer was stationary. Fine. So explanation, what can be the possible explanation? See, whenever a bar magnet is placed near a coil, number of lines of force pass through it. So as the magnet is moved closer, magnetic flux increases. And induced EMF is there. You have studied normal EMF. When EMF is generated because of change of flux or increase or decrease, we call that EMF as induced EMF. We'll see this. This we'll see in detail. That is the probable and possible reason for this. Then one more experiment was conducted. That this time, no, the coil was made stationary. This time what was done? Bar magnet was stationary. South. So let's take this south and that north. And this time the coil was made to move. Coil was in motion this time. So magnetic field lines were existing. Again, galvanometer showed certain deflections. Right? Certain deflections were made by the galvanometer this time as well. And one more experiment was done. Finally, last experiment, which we say the third experiment. Third experiment was induced EMF was done by a neighboring coil. For example, if I say this is a rod, these are certain windings of wire, battery, key connected to rheostat also. Rheostat is just a variable resistance. In current electricity's practical classes, if you had, you must have observed rheostat in your physics lab. That is just to vary the resistance. Sometimes you have to minimize the current, sometimes you have to maximize the current. Galvanometer was somewhat like this setup was done. So here what happened, two coils occur. This is like a primary coil and secondary coil. When we'll do at the end of alternating current lesson, EMI, the next lesson that is coming, we'll see primary and secondary coils in detail. We'll see. So you can leave this for now. So this is based on AC transformer, and one topic that we'll study is induction that we do in this. So you can leave this for now, just make it a note point, we can do it later. So what was the conclusion that was drawn? Whenever the magnetic flux linked with a closed circuit changes. See, magnetic flux linked with a closed circuit can change. Magnetic flux is what? You have to understand. See, this is the very basic concept. Very basic concept. By this, you have to understand it. Magnetic flux is number of magnetic field lines that are crossing area normally. Okay? Number of magnetic field lines that are crossing area. Now, number of magnetic field lines. This is known as magnetic flux. So, if number of magnetic field line increases, number of magnetic field lines increases, then magnetic flux increases. If number of magnetic field line decreases, then magnetic flux also decreases. So magnetic flux can be variable, magnetic flux can change depending upon the magnetic field and magnetic field line. This concept is very core and basic. If you have understood this part, Lenz law, all your lesson is done. Then you directly have to start with motional law. Please pay attention. If you have not understood any part, if you're not able to understand, stop me there. I'll repeat. Any doubts you can ask me. This is the very, very basic topic. So, changing magnetic field produces changing magnetic flux. Now, as the magnetic flux changes, EMF that is generated, no, we call it as the induced EMF, because this is a special EMF that has been developed because of this changing magnetic flux. And how do we know? Because of the Faraday's experiments. As I've told you, all these are done experimentally. Faraday and Henry did certain experiments. So magnetic flux increased or decreased. There was a magnetic field increase, decrease. There was a respective associated magnetic flux linked with it. Because of change in magnetic flux, current and EMF, these two quantities were developed. They were induced. They are artificially produced, or you can simply use the term induced. So that's why we have a special name, induced EMF and induced current. That is what I have written it on the screen. Whenever the magnetic flux linked with a closed circuit changes, an induced EMF, hence an induced current is set up. This point is very basic and core. If you've not understood this line, let me know. I am repeating it again. Still, if you're not able to understand, please ask me. This is very simple to understand. Magnetic field gets changed if magnetic field lines increase, magnetic field at a certain place increase, magnetic flux gets increased, magnetic field decreases, magnetic field lines decreases, magnetic flux will also decrease. This change in the magnetic flux, increasing, decreasing, then remaining the same, then increasing, decreasing, in whichever manner, this change in magnetic flux produces induced EMF and induced current. Fine. Now, the magnitude of this EMF, this is proportional to whatever is the rate of change of magnetic flux. For example, if magnetic flux changes very rapidly with time, rate of change of magnetic flux means what? Magnetic flux that is changing with respect to time. After 5 seconds, magnetic flux got changed. After 10 seconds, magnetic flux got changed. So what's the rate of change of magnetic flux? Like this. So magnetic flux, so EMF is directly proportional to rate of change of magnetic flux. Means if your magnetic flux changes rapidly, there's a huge difference in the change in the magnetic flux, or the change in the magnetic flux is very high. High amount of EMF will be induced and therefore high amount of current will be produced. If your induced EMF, or if your magnetic field lines are lesser, or you can say magnetic flux that has changed, this is lesser. There is a slight change in the magnetic flux, or the difference between the initial and final magnetic flux is smaller. So since this gap is smaller, this difference is smaller, this change in magnetic flux is smaller, value or the change in EMF, that will also be lesser. Induced EMF will also be lesser. Induced current will also be lesser. So second point is that only the higher the rate of magnetic flux with closed circuit, the greater is the induced EMF or current. And vice versa, the lesser is the rate of magnetic flux, or the lower is the rate of magnetic flux with closed circuit, lower is the induced EMF or current. First, tell me, any doubts in these two? Do you have you understood this part?
Yes, ma'am.
Now Faraday's laws of EMI will do, then you can note it down. So Faraday's laws of EMI, whenever it comes in the exam, you have to mention this fact, that whenever, first fact, you have to mention the first conclusion that I had told you, that whenever there is a magnetic flux change or change in magnetic flux, induced current will be produced and induced current EMF will be produced. Fine. Then the second point which I have mentioned is these are actually the laws of EMI. Faraday's laws of EMI, and they come in the questions to answer. Please mark this as important. When you will write, mark it as important, though I'll mark it an asterisk sign over here. Second point says, see, magnetic flux is what? Magnetic flux is phi. Let's say this is initial magnetic flux. This is initial magnetic flux. Phi final is the final magnetic flux. Fine. So phi I is what? This is the initial magnetic flux, and phi final is the final magnetic flux. All right, class. Now change in magnetic flux will be what? Phi final minus phi initial. Rate of change of magnetic flux will be what? Delta phi over delta t. This is the rate of change of magnetic flux. So EMF, no, it is proportional to this only. Got it, class? EMF is proportional to this only. Or you can even write this is directly proportional to d phi over dt. we also put a negative sign in this, minus d phi over dt, right? Here the constant value, no constant, we usually write it as 1. That's why I'm not mentioning any constant over here. Why is there a negative sign? That we'll discuss in Lenz law. And that we'll completely discuss in Lenz law. So right now you just can remember for the timing that a minus sign will be there, but minus sign significance of this negative sign, you can remember it later. Now, E is equal to minus d phi over dt. If R is the resistance, so induced current I have to find. Current is EMF divided by resistance, and EMF is minus d phi over dt. So current will be what? 1 by R minus d phi over dt. One more point. If charge is mentioned, if Q is the charge that is mentioned, so I is equal to dq over dt. From here you can write I as dq over dt, and what was I? 1 by r d phi over dt minus sign dt gets cancelled. dq becomes equal to minus d phi divided by r. So let us just conclude this. I'm repeating this to say. See, whenever there's a change in magnetic flux, how can the magnetic flux get changed? By the change or alteration in the magnetic field. So if the magnetic flux gets changed, the rate of change of magnetic flux will be there, means the magnetic flux will be changing with respect to time. And electromotive force, EMF, that is present, that will be directly proportional to the rate of change of flux, magnitude of it. We put a negative sign, constant here is 1, k is 1, so no need to put a constant. So E is equal to minus d phi over dt. Why do we write this minus sign? We'll do it in Lenz law. For resistance, use Ohm's law. For current, use the definition of charge. What did class? Any doubts in here? This is very important. That's why I'm continuously asking you about this. Do one thing. Start noting from here wherever you get stuck. Type your doubt, type your question. Let me know whatever doubts you're having. This third one, Samia, or the second one? Which one?
Ma'am, the third one.
This third one. See, third one you'll not be able to understand because we have not done induction. No. So, see, third one is basically induced EMF by varying current in the neighboring coil. So, two coils are there. First is the primary coil, second is the secondary coil. They are connected with tapping key system. When the tapping key is pressed, then the galvanometer shows a momentary deflection in one direction. And when the key is released, it again shows a momentary deflection but in opposite direction, exactly in the opposite direction. Now, if the tapping key is kept pressed and steady current then flows through the primary coil. So when current flows only through the primary coil, no, then there is no galvanometer deflection. But when the resistance through the help of rheostat is increased and induced current flows into the secondary, same thing occurs that had occurred in the primary. Fine. So deflections in the galvanometer become larger if we use a cylindrical support made up of iron. The cylindrical support, no, this figure, this one. This is there. Then mutual induction occurs. A primary coil is there, a secondary coil is there. So mutual induction for primary and secondary coils, all these that we'll study in detail later on. But you just have to remember if induced EMF is if a magnetic flux is changed in the primary coil. Just remember this one line, Samya, and others as well. If magnetic flux is changed in one coil, then the induced EMF occurs in the second coil. This is what is there. Detail we'll see later on. Why is this occurring? That you get to know through Lenz's law also. Magnetic flux gets changed in one coil, EMF is induced in the other coil. Got it?
Yes, ma'am.
Walaikum assalam, Fahad. See, we have continued with the Faraday's laws of EMI. So Faraday's experiments were there. These are not necessary. You just remember this fact. This is essential for the upcoming topics as well. See, increase in the or decrement or increment in the magnetic field lines will produce what? Change in magnetic flux. Because magnetic flux is what? It is ultimately the magnetic field lines only. So, whenever magnetic flux gets changed, there is an associated change or occurrence of EMF and current, which we call as the induced EMF and induced current. So, remember these from here, you can remember Faraday's laws of EMI. Whenever magnetic flux linked with a coil changes, EMF is produced, which is induced EMF, and induced current is produced. And this magnitude of this EMF, yes, I am scrolling. Sorry. So whenever induced EMF is there, its magnitude is directly proportional to rate of change of magnetic flux. These 2 points, if you have remembered, then it's well and good for your upcoming topics. And as was announcing, I'm repeating this again. Again, you will have a test on 20th of September. Same. Induced EMF, Fahad. See, induced EMF means EMF, electromotive force. We have studied terminal potential, internal resistance, and EMF. So, induced EMF means an EMF that has been induced because of change of magnetic flux. So, as the magnetic flux gets changed, there's a change in the magnetic flux. That EMF that is being produced, that we call as the induced EMF. And you people have not scored well in your test except one student. So again, I'll take the same test on magnetic effects of electric current on 20th of September. And please try to improve your scores. Please practice. What was the issue? Just a lack of practice, I hope. So same thing, I've discussed it with other students. Just Fahad, you were not there. So please prepare 1 week time you all have. Please prepare for it. Written. Let's practice certain questions now. A 10 ohm resistance coil has 1000 turns, and at a time 5.5 into 10 to the power minus 4 Weber of flux passes through it. If flux falls to 0.5 into 10 to the power minus 4 Webers in 0.1 seconds, you have to find the EMF generated in volts and the charge flown through the coil in coulombs. Formula based, right now also only you have written the resistance is 10 ohm. Initial flux 5.1 is 5.5 into 10 to the power minus 4. 5.2 is 0.5 into 10 to the power minus 4. False, no. If flux, yes, this is the final flux. Time is 0.1 seconds, and what I have to find? EMF generated. Find EMF. See, EMF will be minus d phi over dt. Change in flux is what? See, change in flux is final flux minus initial flux. So 0.5 into 10 to the power minus 4 minus 5.5 into 10 to the power minus 4. Just the subtraction of both the flux will give you the difference. So this will be 5 into 10 to the power minus 4 Webers. So EMF will be 5 into, no, this will be minus 5 into. So minus minus will become plus, so that's I'm writing plus here. 5 into 10 to the power minus 4 divided by 10 to the power minus 1. Was it 0.1 or 0.01? This will go up, it will become 1, so this becomes 5 into 10 to the power minus 3 volts. Got it, class? Charge also we have to find out, no? Charge formula also we have done. dq is minus d phi by dp. So minus again, minus into minus, that will give you 5 into 10 to the power minus 4, not dt, divided by resistance. How much is the resistance? 10. This will be 5 into 10 to the power minus 5 coulombs. Positive in this manner. See, flux is what? Flux is 5 2 minus 5 1. So 0.5 minus 5.5. From a lesser, you're subtracting a bigger number. That will be minus. So this minus is there. And in the formula also we have the minus sign. No, this minus sign. So this minus and this minus. That will become plus over here. Got it? Note down this one more question. Let's do. says that third question says that a coil of cross-sectional area A lies in a uniform magnetic field with its plane perpendicular to the field. In this position, normal to the coil makes an angle of 0 degree with the field. The coil rotates at a uniform rate to complete one rotation in time t. Find the average induced EMF in the coil during the interval when coil rotates from 0 to 90-degree position and 90 to 180-degree. Class, first note down this question, then only you'll be able to understand. First note it down, just have a look at this question, then I'll discuss it. Try to solve this if it's possible. You just have to vary time period. See, this question says what? Magnetic field is present and a coil is there. So let's say this is the initial, this you will see again in AC dynamo, AC generator, we'll see the same principle. So coil has this initial position. Let's say this is, then the coil rotates in the 1/4 of time. Then in the half time, the coil reaches this position. So then first position of coil 90 degree, total 180 degree, that is the half time. Then this becomes what? This total angle. This becomes 270 degrees. And what's the last angle? Ultimately, it will revolve. This will become 360 degree. Got it? Coil has started its rotation. So 90 degree, 180 degrees, 70 degree, 360 degrees. Yeah. Total time period for reaching this 360 degrees capital T. So can anyone answer this fact? If it, see, total time period to complete this one rotation, this is capital T. So if the coil is moving only to 90 degree, what will be the time period? Complete for 360 degree, it's T. For 90 degree, it will be T by 4. Yes, Priya and Madiha. Priya, Darshini and Madiha, correct. It will be T by 4. That's the only difference that will come, and you now solve all the parts. Others have understood why is it T by 4? Because you 360 is divided into 490 degrees, 190 degree, 290 degree, makes 180 degree, one more 90 degree, 270 degree, one more 90 degree, 360 degree. All these make 360 degree complete. So here the time period will be that. So phi at 0 will be what? Initial phi. Cos 0, BA cos 0 degree. That will be BA. Phi at 90 degree will be what? BA cos 90 degree. This will be 0. So initial flux we have. This is what? This is initial first flux. This is the final flux. Got it? This is the initial flux and this is the final flux. Now, EMF will be minus d phi over dt. And time period, your time period dt will be capital T divided by 4. d phi is what? Phi 2 minus phi 1 means 0 minus d phi is what? 0 minus BA divided by T by 4. So that becomes 4BA divided by T. This is the answer for the first part. See, from 90 degree to 180 degree, can anyone answer this? From 90 degree to 180 degree, what will be the time period? See, from 90 degree to 180 degree, it will be what? From here it is, this is 90 degree to 180 degrees. How much will the time period will be? 90 to 180 degrees. Priyadarshini is right. Somebody else also try. Total 4 parts are what? Total your 4 parts are what? These are capital T. This is completely making capital T. 0 to 90, 90 to 180, 180 to 270, 270 to 360 divided in 4 parts. So this will be what? 90 degrees. Others also answer. Sahal, Samya. From 90 degree to 180 degree. How much fraction has been covered out of the complete 4 part? Abia. Yes, Madhya, it will be T by 4, C class. All those who are answering T by 2. T by 2 will be when you start from 0 degree and then you move T by 2 plus T by, means T by 4 plus T by 4. When you're covering half of the journey, when you're reaching from 0 degree to 180 degrees, that is T by 2. Right now your initial position is 90 degree. So you're starting from 90 degree to 180 degree. So it's simple, same. It's like from 0 to 90. This is T by 4. Similarly, from 90 to 180, it will be T by 4. From 180 to 270, it will be T by 4. From 270 to 360, it will be T by 4. But when you have, for example, 0 to 180 degrees, 0 to 180 degrees. That is half of the time. And that half of the time means t by 2. So this is t by 2. Like this. Got it, class? So here also from 90 to 180 it will be same. So this becomes BA cos 90 degrees, which is 0. 180 degree will be what? BA cos 180 degrees. That will give you minus BA. This is your initial flux. This is your final flux. So EMF will be what? Minus G5 over dt. No. So minus G5 minus BA minus 0 divided by T by 4. dt will still here be T by 4. So this again becomes 4BA by T. All right, note down this one. Any doubts in this question? You can ask. Any part can be asked to you. 270 to 180 degree, 180 degree to uh, if it's 180 degree to 270, it will be T by 4. If it's 90 to 270, T by 2. If it's from 0 to 360 degree, completely T. Just text me done when you will complete the writing part. Lens law, I'll do it in the next class. Lens law is left and induction is left. Magnetic induction. Okay, all the students who have completed, you can leave. Next Tuesday, you will have the test, and in the next class, we'll continue with EMI. Lens law, we'll start with. Okay, thank you so much.